Hello, everyone. This video will be going over our Algebra 2, Chapter 2 unit test. So going through each problem, we're going to go ahead and start with number 1. Number 1 is asking us for the function f of x equals x squared minus 10x plus 24 to a, find the x-intercept. So that's where we're going to start. So in order to do that, I'm going to go ahead and rewrite our function here, that being x squared minus 10x plus 24. And in order to find the x-intercepts, I must change this equation from standard form into factored form. Factored form is the form of the equation that gives us our x-intercept. So I'm going to go ahead and start my box over here. Now, we learned two box methods. One of them was factoring, one was completing the square. For factoring, we always start by putting our first term and our last term inside of our box. From there, we must look at our first and last term, 24x squared, when we multiply them, and break them up in such a way that we could break up 24 via multiplication so that it adds up to be our middle term, negative 10. So the way that we do that is by looking at each component. There's only one way to break up x squared, that being x and x. So we put an x value in each box here. That deals with our x squared component. Now for the 24, we need to find two numbers that multiply to 24 that add up to be negative 10. So if we list out the combinations, we get 1 and 24, 2 and 12, 8 and 3, and 6 and 4. All these numbers multiply into 24. And after considering each of them, we notice that 6 and 4 will give us the value of 10. However, what I want is a negative 10. So 6 and 4 aren't quite going to work. What I need to do is I need to make both of them negative. Now, this works because negative 4 times negative 6 still gives me positive 24. But when I add them, it will be negative 10. So using the negative multiplication property, a negative times a negative is a positive. I can use negative 6 and negative 4 to add up to be my negative 10. So I found my values that work. Once I have that, I plug them back into my box. And now my box is filled out. So now I could factor this box. So I'm going to just separate my x squared into x and x. X times negative 4 gives me negative 4x. I go and place it on the outside. And x times negative 6 gives me negative 6x. And of course, I check my my last intersection. This negative 6 times negative 4 gives me 24. As previously discussed, it does. Meaning my factored form is x minus 4 times x minus 6. I'm just taking my information from my box here and I'm taking my outside terms and putting them inside parentheses, rewriting this as a expression. From there, all I need to do is set my factored form equal to 0. Remember, x-intercepts are where the graph passes through my x-axis. So that means that when the graph passes through my x-axis and I get my x-intercepts, my y value is 0. So that's why I'm saying this equation equals to 0 to evaluate this expression when y is equal to 0. And when I do that, I need to test. When does x minus 4 equal 0? And when does x minus 6 equal 0? Now, quite a few people skip this step. What they'll do is say, oh, I have negative 6, negative 4. Those will be my x-intercepts. That is not the case. You must follow this step because oftentimes the signs will change when you're trying to solve for 0. For instance, 4 minus 4 is equal to 0. So one of my x-intercepts will be 4 comma 0. That's for this one. If I put a -4, they would not cancel. So you need to make sure that they cancel. Similarly here, I know that 6 minus 6 will give me 0. My x-intercepts will be 4, 0, and 6, 0. Now that I have my x-intercepts, I am done with part A for right now. And now we'll go on to part B, where it says find the coordinates of the vertex. So what I need to do from there is I need to once again take my original function, x squared minus 10x plus 24. And rather than factor, this time I'm going to complete the square. So this is the second box method that we learned. But rather than fill in my first and last terms, my first and last boxes, I'm going to fill in my first term into my first box, and then I need to split my x's. I'm going to split the x's into my second and third boxes here. So what do I mean by split the x's? Well, if I look at my second term, I have 10 x's. All of them are negative. So I have negative 10 x's in this expression, in this function. So I need to split them evenly. The process is referenced in the name. Complete the square. Squares are even on all sides, so I want to make my box here even on all sides. So I need to split my x's evenly. So negative 5x is going to go here, and negative 5x is going to go here. So that this side is x squared and negative 5x, and this side is x squared and negative 5x. So if you ever forget how do I set a complete the square, there's a clue in the name. Make sure that all sides are even when you make your box. Now, if that being said, I still have this missing value here. And the way that I find that is by multiplying negative 5 times negative 5. I'm pulling these values from my second and third box respectively, and I'm going to multiply them to get positive 25. So I have now completed the square, or at least found the box in order to complete the square process. But in order for me to use this box, I need a 25. And I don't have a 25 off 24. So in order to use this, I need to figure out how to get a 25. And then what I do that by adding 1 my function. However, I can't do that for free. I can't just change the equation however I want. In order to balance things out, if I add 1, I must also minus 1. From there, I could rewrite this as x squared minus 10x plus 25 minus 1. And now this part of my function matches the box that I have here. So now I could factor this box and use the result in my problem. I'm going to factor x and x, negative 5 and negative 5. So this becomes x minus 5. And rather than write the same thing twice, because both sides are equal, rather than write both parentheses twice, or the parentheses twice, I'm going to just write x minus 5 squared. And of course, I need to tack on this minus 1, thus me minus 1. So I'm done completing the square, and now I have my vertex form. But the question is not asking for vertex form, it's asking for my vertex. So I must look at my h and k values, which will then give me my vertex of 5, negative 1. Remember our h rule. Whatever our h value is, we always must do the opposite. So this is my vertex, and I am done with part B. Part C is really just joining and checking that I did parts A and B correctly. So it says using the points from parts A and B, graph the function. So I'm going to look at my x-intercept source. I'm going to have 4, 0, 6, 0. And if I did everything correctly, my vertex should be in the middle of my two x-intercepts. So that would be 5, negative 1, which would be here, which indeed does match up with my expectation. I connect the dots, forming a parabola, and I have my graph for part C. And that completes question 1 for our Unit 2 test. Moving on to number 2. Number 2 reads, during a weekend game at the park, a student punts a football downfield. The ball rises into the air and reaches its highest point of 15 feet. As I'm reading, I'm highlighting important information that I'm going to use to answer my question. After it drops back down, it lands on the ground 20 feet from where it was kicked. So it lands 20 feet from where it was kicked. Once again, I have 2 parts. My part A says sketch the scenario. I'm going to go ahead and start by drawing my 2 axes, my y-axis and x-axis, and I'm going to fill in the information from my word problem. So the scenario says that I am 15 feet high at my highest point, and I move 20 feet from where I was. So I know that my ball is going to arc up and then arc back down, and I just have my points align with my values that I put. So making that match a little bit, not the best artist, but so long as I have a rough sketch of the scenario, that should be fine. I reach a max height at 15 feet, and I go a maximum distance of 10 feet. Or excuse me, maximum distance of 20 feet. Getting ahead of myself. And of course, as far as sketching the scenario, I am done. But in order to do part B, where part B says find the equation of the path of the ball in vertex form, in order to start that, I must identify what my vertex is. So I need my XY coordinate, which I know I'm 15 feet high, so I input that for my Y value. My X value, I'm not entirely sure. I know that it's right here, but how can I know exactly where that is? Well, something we remember from our lesson and even from problem 1 is that my vertex is always in the middle of my 2 x-intercepts. So here my x-intercept, I start at 0, I move over 20 feet. So that means that my vertex must be at 10 feet, and my vertex will be at 10, 15, which are essentially going to be my h and k values for my vertex. So that means that I can start plugging in values. This is equal to y equals a x minus, rather than write a, so I'm going to write minus 10 squared plus 15. And this gives me my h and k value. The last thing that I need to solve for is my a value. Now, I also have 2 other variables. So I have y and x. So I can't solve for the value of one variable when I have 2 others. I can't solve when there are 3 unknowns in an equation. So what I need to do is give these x and y's a value. And how I do that, by looking back at my sketch. I know that this graph goes through the point 0, 0, point is 0, 0. And I know that this point is 20, 0. So I could use my x-intercepts in order to help me find what my plug in for x and y, which will then allow me to solve for a. I encourage you to use 0, 0 whenever you can. Just makes the calculations a little bit easier. So I'm going to plug in 0, 0 for my x and y value, giving me 0 is equal to a times 0 minus 10 squared plus 15. Now I'm going to have one unknown. So now it's just a matter of simplifying and solving for a, getting a by itself. So that process looks like I first need to do my parentheses. This is 0 minus 10, which gives me negative 10. Negative 10 squared is equal to 100. So what I just did now is simplify my parentheses, but I haven't resolved anything else in the equation, so I need to drop everything else down. So it's going to be 0 is equal to a times 100 plus 15. And now I'm going to go ahead and solve for a, because I need to get a by itself. So the way that I do that is by first getting rid of this 15. The way I get rid of a plus 15 is by doing minus 15. And of course, with what I do on one side of the equation, I must do to the other. Meaning, I will have negative 15 is equal to a times 100. Now I need to get rid of this 100. Now, whenever we have a number or variable next to a parentheses, the operation is multiplication. Meaning, in order to get rid of my 100, instead of doing multiplication, I must do the opposite. So I'm going to divide both sides by 100, and my A is equal to negative 15 over 100. Or if we plug this in the calculator, that should be negative 0.15. Which is my last step. However, I need to make sure I fill what part B is asking. I need to actually write out the equation with all its parts. So my final answer is going to be y is equal to negative 0.15 times x minus 10 squared plus 15. And that is my final answer. Moving on to part number 3. So this one, we're looking at a parent function. Given the parent function of line 1, root of x was the equation for line 2. So I announced this during class, but also we should remember our facts about parent functions. I know that this one is line 1 because the parent function starts at 0, 0, passes through 1, 1 is positive. This has all the qualities of a parent function, meaning that this is line 1, which means I need to figure out what the equation is for this one, line 2. The way that I do that is by looking at my vertex form. My equations for all my other type of parent function are going to be based on my vertex form. So I'm going to have some version of A, H, and K inside my parent function for this one. Or excuse me, apply to my parent function. It's not going to be a parent function anymore once I transform it. So what I do first and foremost is look for my new starting point. My line 1 started at 0, 0. My line 2 starts at negative 3, negative 2. Meaning that my H is going to be negative 3, my K is negative 2. So I'm going to start going and writing that out. I know my H value is always directly next to my X value and is inside of whatever's happening to X. So I know it's going to be under my radical. So I'm going to write X plus 3. Now the reason that's plus is because our H rule. Whatever H value we have, we must do the opposite. But if you really want to math it out, since our original equation, our original H value is being subtracted, we have X minus H. This would be X minus negative 3. Of course, the negative, negative make it positive, meaning that this turns into X plus 3. Our K is always tacked on the end outside of our operation. So I get X plus 3 minus 2. And I'm not asking to look for an A value, but what I do need is for you guys to tell me if it's positive or negative. By positive, I mean as my X values increase, what does my line do? For line 1, it's positive because it goes up. For my line 2, I'm going to say that it's negative because it goes down. And this is my final answer. Why can't I make a box around any of my answers? This is my final answer. F of x, if you want to be fancy, f of x equal to negative square root of x plus 3 minus 2. Now, when we come to step 4, or part 4, question 4, it reads, for each of the following equations, describe how the graph will transform from the parent function. So, I give you the parent function below for part A and part B. So the parent function for part A is f of x equals x to the third. So when I'm comparing the function I give you compared to the parent function, the first thing we need to do is identify all the differences. So the main differences are our parent function does not have a plus 2, nor does it have a negative. I do not circle the 3, the exponent 3 here, because that comes from our parent function. There are no changes when it comes to the power here. I have the power of 3 here, I have the power of 3 here. Power of 3 is not one of our changes. Now, that being said, my negative and 2 are changes. So now that I've identified the changes, changes, I need to describe what those changes are. This negative will reflect my graph, F, reflect our graph over the x-axis. It will make it from going in a positive direction to now going in a negative direction. The technical way we say that is reflective of the x-axis. Our 2 is a k value. Now, the reason I know it's a k value is because it's outside of what's happening to x. If it was inside parentheses or inside whatever's happening to x, I would be considered an h value. But since it's just here at the end, separated from what's going on for x, this is a k value. Our k value effects are vertical, so I know that this is going to be a shift of going up by 2. And to be complete and to write my final answer, I just need to put those together in sentence form. So I'm going to say the graph reflects over the x-axis and shifts up by 2. And that's all I'm asking for part A. For part B, I once again look at my parent function and try and find all the differences here. The differences being, once again, I have a negative. I have a +4 directly applied to my x, and I have this 5. Once again, our negative is going to reflect our graph over the x-axis. My 5 is on a k value. This time I'm going to go down 5 because it's negative. Now, my 4 is directly affecting my x value, making this my h. Now, the rule for h is whatever I have my h value, I must do the opposite. So even though I have a +4, that means that I need to treat this as a -4, which means I need to go in the negative direction for my x value. That would be going left by 4. I need to move left 4 because on my graph, this is the positive direction, this is the negative direction. So since I need to treat it as opposite, I must go to the left by 4. Okay? And I don't really like how that was written out. Let's make it a little bit cleaner. Okay? Now, when all is said and done, I need to go and still write this as a statement. So the graph reflects over the x-axis shifts or to the left and 5 down, thus completing our question number 4 and completing the test. If you have any questions, please go back and review each of these problems in this video, or else come with questions that I can answer for you in class or during tutoring. Happy studying and best of luck on your recovery.